Welcome to the podcast, Creating Value in Travel and Transportation, hosted by Landry Holy, CEO and founder of Fairval. In this podcast channel, we will exchange with entrepreneurs, industry experts, financial institutions, and investors on how they contribute to creating value in various travel verticals, thanks new innovative tech solutions and financial services. So, if you have an interest in travel retailing, hospitality, urban mobility, maritime, aviation and space tech, then this podcast is for you.
Hello everyone and welcome to this new episode of our podcast Creating Value in Travel and Transportation. With over 300 daily flights to around 150 destinations, KLM has maintained a prominent position as a leader in sustainable practices and passenger-centric innovations. For example, KLM stood out when it was one of the first airlines to use sustainable aviation fuels, implemented blockchain technology for transparent supply chain management, and introduced the Care Tag, a GPS-enabled audio guide to enhance travelers' experience in Amsterdam. Yet, KLM aims for a bigger picture when it comes to deeply transform the aviation industry, and this thanks to game-changing emerging technologies. But how? Well, to share such insights, we have with us today Asteris, Apostolidis, Director leading technical innovation and emerging technologies at KLM Blue Labs. Hi Asteris, how are you?
Hello, hi Landry. Great, to be here. Thank you very much for having me.
Thank you for joining. So maybe just to start the session, could you give us a bit more about your background, your journey, and how it brought you to KLM Blue Labs, basically?
Yes, that's a nice question. It brings me back to where when I was a student. Well, I'm Greek originally, so I used to live in Greece. I studied mechanical engineering. And then, throughout this journey of studies, I started discovering topics such as aerodynamics and such as thermodynamics, things that I really, really like. So that's the moment when I decided that, I should do something with aerospace or aviation. And this is the point where I decided to direct my career towards that direction. Anyway, after having graduated and after having a specialization in aeronautics, I moved to the UK. I was very lucky to get sponsored by Rolls-Royce, the engine manufacturer, for my master's over there. I did my thesis with them on the Trend 900, simulation framework for altitude relight for the engine. So it was about safety and how it can enhance the relight capability of the engine. And apparently people were happy with how this turned out to be. And then they asked me if I could stay for 3 more years to do a PhD there at Cranfield University in the UK. And I stayed for 3 more years, also developing different kinds of simulation methods for aerothermodynamics. And that was mostly, again, on turbine cooling and how we can use physics to predict engine design when it comes to cooling. So that was a very specific and very special technical area. But in fact, to be honest with you, my inspiration always comes from the fact that people can travel, people can just take the plane and travel somewhere. That gives me this kind of sense of freedom. So that's where I wanted to be. Long story short, after the UK, I spent a few years in France working for Airbus in the development of simulation frameworks, again, in the same kind of technology. So basically, simulation tools that can be used to design and develop systems on the aircraft itself. So mostly for the packs, for the environmental control systems, engines as well, anti-icing systems. And then, for some personal reasons and some, professional reasons, I decided back then with my family to move to the Netherlands. And I was very happy to come across KLM because, in fact, after some discussions, KLM decided to hire me back then to start their activities on engine predictive maintenance, which means that, back in the days, KLM were producing lots of data, but when it comes to engine maintenance, few of them were used, or we could do better by using data to optimize engine maintenance. I stayed there, we developed some really nice solutions for a couple of years. And then it was time for me to move again. I moved to the CI office of the Air France KLM group, doing technical innovation technology, so a similar role compared to what I have right now. Then COVID hit. So I switched back to academia for 2 years, and that's, let's say, another passion of me. So I'm, let's say, a hobbyist researcher till then. But for 2 years, I was a professional researcher. Like I used to work as an associate professor for MRO engineering. So again, like applying AI-based solutions in aviation. And then I returned to KLM roughly a year ago, a bit less than a year ago. Again, working on technical innovation and basically. My department coordinates technical innovation across the whole KLM mother company. So, everything under KLM is within our scope, and that's a very nice place to be honest with you. That's my journey, more or less. Plus, I'm part of different working groups, mostly related to AI and aviation. So, I used to co-chair the SA EuroK International Working Group on AI for aviation. So, looking into certifiability of AI for aviation. And also, during the last year or so, I work with IDCA, that's Independent Data Consortium for Aviation, developing the framework to make data shareable and develop the standards that can enable data sharing among different partners. Either being partners or competitors, we see value in both cases. So that's very briefly my journey, but in fact, it's a journey that I really enjoyed so far.
Yeah, well, very impressive. I mean, it's really interesting to see that you're going back and forth, companies, then research. So with a really rich background in different aspects of the aviation, actually, not just the AI, but also all the energy aspects. So really impressive. But I'd like to ask you a question because I mentioned Blue Labs. And we definitely see how important is innovation for KLM, which amongst various airlines, I have to say it's one of the airlines which, we clearly observe being very active. Could you just tell us a bit more about Blue Labs, the mission, the drivers, and maybe a couple of, projects which are ongoing that you can, of course, disclose?
Yes, of course. I'm very happy to do that because, in fact, I think the Blue Lab set a very good example of how innovation can be done within an airline. Well, it took us some time to come up with our operating model, so that was not just an easy task, but in the end, I think it was worth it. So the Blue Labs is, let's say, I can describe them as a central coordinator for technical innovation across the whole KLM company. And of course, an airline, it's like an umbrella company, including different departments that they do totally different stuff. You think about, of course, like flight operations and ground operations and the companies that they own, like the assets, so equipment services. And then you have maintenance and engineering, you have catering, you have cargo, you have you name it, commercial, digital, IT. It's like all kinds of different professions and disciplines fall under the scope of an airline. So it's a very diverse environment, and for me that's a very nice environment as well, because I'm very curious by nature, so it gives me the opportunity to look into all kinds of different problems and solutions. So the Blue Labs, basically what we do is that we partner with different business units and departments across KLM, and we develop labs, as the name implies. So what we do is that, let's say, we partner with ground services, and then we create a ground lab. And within this ground lab, we try to understand the business challenges of this part of the company, and then together co-create the solution. So we don't really develop solutions for our internal customers, but basically what we do is that we develop solutions with them, and that's a difference that we see. That's let's say a main point into our operational model, because this way we keep our colleagues engaged. If you just go to a part of the company and you just discuss about what issues they face, and then you disappear for a few months and come back with a solution, the chance of getting adopted are relatively low, I can say. Why? Because you don't take into account all the different details and different, let's say, specifics of that specific department. And also people, are engaged. They need to feel engaged. They need to, just have this kind of daily interaction with you. So in that sense, that's what we do. And we're a new department, meaning we're pretty young now, but we expand. And hopefully also our labs will keep expanding. A couple of examples, as you asked, is it's not a coincidence that I mentioned ground services, because a few months ago we started a ground lab with ground services. And one of the biggest challenges that ground service colleagues face is physical labor. Let's say, we see in the news as well, like people working with heavy loads and luggages, and let's say all this kind of heavy labor. It's something that has all kinds of health implications, and we want to help those colleagues basically. So what we do is that we use all kinds of technologies. So I can mention a couple of them. One is like using sensors that they monitor how the body moves, so we can understand what kind of moves are supposed to be healthy and what not. Also, can use computer vision to scan our colleagues when they work and understand how they use their body when they work with heavy loads. And then by analyzing this, you understand what are the physical strengths in the body that they have. And of course, we use computer vision is by definition AI. So essentially, we use AI to understand what are the challenges when it comes to physical labor. And as a next step, second step, the idea is to try to address those problems with, again, technology. So it can be exoskeletons, it can be like cobots, it can be all kinds of stuff. That's what we currently scout for, to understand how those issues can be tackled. Because, that's a very, important problem internally as we see it. That's one example. Another example is also what we call, in fact, an interesting part is the following. Those technologies that we use, we consider them mature, or at least they are in operation outside KLM, and we want to make sure that we can import them and use them successfully within KLM too. But apart from that, we have what we call the Emerging Technologies Lab, and this is a lab where I'm very much involved with. And this is where we identify technologies that we don't think they are mature yet to be implemented directly into the business, because the scope is to bring them into production. But we see some very promising stuff out there. And what we do there is that we might do a pilot with some of the businesses and explore the details of this technology and the feasibility. And of course, if it's promising, we can move forward. But in any case, we keep those technologies, let's say, in our radar. And once we identify the right moment that we think they can be tested and deployed, even then, this is when we act with them. Think about again AI, data, digital twins, things like that. And that goes in the operational side of the company. It goes in other parts of the company as well.
Very interesting. I think what is really good about the approach is the fact that you really involve the business units, and that is a pragmatic approach to kind of really generate value, not in too long-term perspective, but could be in the short term. And of course, your approach with emerging technologies is also the right one, because you have to test and you have to keep that on the radar until it becomes mature. But having a first knowledge gathered is, I think, really key. And so, having said that, I like to focus for a couple of minutes, or maybe a bit more, actually, on everything around AI, data technology, because this is the major topic today impacting all industries. Actually, this week there is in Cannes a major event around AI, which is gathering people around the world.
Mm-hmm.
So this is definitely becoming a mainstream technology. And I like to think more from a short, mid-term perspective, because that's, I think, the I wouldn't say the technology is fully mature, but it's getting to a stage where it's really interesting. And I'd like to ask you to give some examples what KLM is doing or aiming to do in 3 core domains. The first one would be around operations, airline operation. Second one around business models, and the third one around customer experience. So if we start with operations, coming from that industry as well, used to be nightmares around things around irregular operations, optimizing maybe fuel, or any other topics you may want to talk about. Happy to get your views there and your inputs on what's happening on your side.
Yes, well, that's a very good question. In fact, I think that's the core of what an airline does, or at least the core of, let's say, the biggest challenges that an airline faces. So if you think again of an airline from a macroscopic level, you're going to see that an airline is a huge scheduling, optimization, and rostering problem. Everything needs to fall in the right place at the right time, and think about how you schedule the fleet, how you schedule like crew, how you schedule the ground operations, how you schedule passengers, how you schedule, I can keep going, like maintenance, how you can schedule like cargo and like when to load, unload, and so on. Catering, did I mention that? Well, in any case, like, everything needs to be at the right place at the right time. And of course, like follow specific constraints, follow specific rules, and so on. So I think that's the core of the problem that airlines, the challenge that the airlines need to address. So of course we use data, and of course like we use data more and more to understand what is the current operational status, and like also be predictive about the future of the operations. Right now we have, let's say, a very large amount of models that they use data that help us understand in the operational side what is the status, what is, let's say, how we can plan things better, how we can schedule things better. And that's for the present. So basically, whenever there is some kind of disruption, we can use tools to identify different scenarios and take the right actions. But of course, and that's not just about KLM, I think that's the case everywhere. Like these problems are, most of the times so big in terms of their scope that the solutions that we come with are, sometimes suboptimal, meaning that, you try to solve problems, but those problems are so complex that you don't always have the capacity to solve them completely. So, in the end, you come up with good enough solutions, and that's, let's say, where you are at. However, we see, like things advancing very, very quickly. So we try to be at the forefront of those developments. We try to keep production, let's say, of course, like, our operations are the core of the company. So we don't experiment things in real environments, but we try to test things also in isolation. And I mentioned before the example of a digital twin, and I think that's a very good example. Why? Well, a digital twin, in my opinion, is like, it's a very hyped term lately. But it is for good reasons. Like it's about what we used to call simulation. Or simulation might be a bit like broader, but it brings simulation together with, let's say, high quality visualizations most of the time. An example I can give you is that, one of the critical processes of an airline, and that might be very familiar to people who travel. So basically for everyone, is the turnaround process. So basically the moment that the aircraft reaches the gate till the moment it leaves the gate. And then during that period of time, all kinds of different processes need to take place. So you need to deboard the aircraft, the passengers need to leave the aircraft, you clean the aircraft, you provide catering again, you refuel at the same time, you start, let's say, the loading of the luggages. I can go on. Basically, it's like a pretty it needs to happen quickly, and it needs to happen the right way. And of course, there are all kinds of different disruptions that can happen at this point, because, for example, there might be disruptions related to passengers, there might be disruptions related to, let's say, the operational side on the ground, you don't have the right resources at the right time when it comes to luggages, fuel, or whatever that may be. So things, can go and, always will go the wrong way sometimes. And that's something that, most of the times you don't have control over, or at least for now. But a very important part is how you react on those kind of disruptions. Why? Because if you know what's the situation and what are the possible different options that you have, then you can act accordingly and minimize the impact of those operations. And by the way, something important is that if something goes wrong in an isolated operational incident, then that might have this kind of domino effect to other parts of, let's say, the operation. So, for example, if for some reason an aircraft is delayed, that can impact, let's say, the aircraft next to it, and so on. So it's not just an isolated incident; it can have this kind of general impact on the operations. Another example there is that we experiment with digital twins, and this is why we can try to simulate the operations during turnaround, for example, and there, we simulate cleaning, we can simulate other types of processes. And a very useful and very powerful tool there is that those kind of simulations can be modular, which means that if you, we can simulate something in isolation, again, cleaning, or let's say boarding, or whatever. But thing is that what are the interdependencies of those kind of different processes? So, for example, if you try to do cleaning and catering at the same time, you might see that, for example, the physical space in the aircraft is not enough to do that. By visualizing stuff and by using also data and even AI, so to try to be predictive, you can basically anticipate and take actions on those kind of events and design your process accordingly on the first level. But of course, if you go live and you start using those kind of tools, that's not the case yet, but it might be in the future, then you can use those tools in real time to explore different scenarios about the future and then take the right decisions as ground staff on what you need to do at the right time to minimize the impact of those kind of disruptions. Well, that's one example. I can mention quickly fuel if that's not an issue, and then I hope that's also something that I can quickly go through because fuel it's also important. And then of course, there is for very very good reasons there's a huge discussion about sustainability in the aviation domain, and I'm totally on board this kind of discussion. And of course, let's say the major polluter in the airline industry is CO2 emissions. And of course, CO2 emissions are a direct function of the fuel that you're using. So minimizing fuel consumption, it means that you minimize by the exact same degree your CO2 emissions. So fuel management is very, very important. And then, AI can be used in different ways. So for example, think about using AI in engine maintenance, and then, you can optimize maintenance in a way that you expand it into a fleet level, and then you make sure that your fleet complies with some kind of, let's say, health standards that can also minimize fuel consumption, because something coming from the engine side, basically, something which is evident to me, but not maybe that evident outside, is engines that are more deteriorated, they burn more fuel, which translates into, let's say, more CO2 emissions. So if you can optimize on a fleet level the health of the engines, that's by definition a sustainable practice. And then we talk about D-rate, for example, how you can manage D-rate. So how aggressively you take off that D-rate, and that's also something important to manage. And you can use data to understand what are your operations and how you can improve them when it comes to applying D-rate. It's about trajectory optimization, and of course that's also that falls into the ATM, air traffic management territory, but that's an important interface that we need to address. It's optimizing flight level. So for example, we see that flying in different altitudes impacts consumption based on the wind, based on other kinds of factors. Also altitude influences the contrails as well of the aircraft, which is another effect that we see. And of course, talking about traffic management, something that, again, is not on us, but it's very important, is to discuss the fragmentation of the airspace and how this can be addressed with traffic management. But all these problems basically can be improved and can be facilitated by using AI and data in general. And last point here is that SkyTeam and KLM, a major member of SkyTeam, every year we organize a so-called Sustainable Flight Challenge, where many airlines under the SkyTeam alliance we perform flights with the aim to make them as fuel efficient as possible by applying all those kind of different technologies at the same time, and then share the learnings from this challenge, and try to implement all those learnings the best way possible into our main operations.
Very, very interesting. I know now why airline is a heaven for engineers, because it's there's so many topics to manage. But having said that, airline is also a business, and as I mentioned, I'd like to see your views on the impact on the two other aspects, which is the business model and the customer experience. And on the business model, I'd like to hear your views on how AI it could be used, or because you kind of touch base on the digital twins, which I think is really interesting. And what I have behind my views is that something happened in the industry a couple of decades. It was the low cost carriers model, which was challenging the hub and spoke approach. With a highly efficient process operations and doing point to point. And we see that, the scenery, the type of new aircraft that are coming on board, and we'll talk about that later on, will dramatically change maybe some of those, traditional models, and up to the point of, the aspect of multimodal practices, which again is becoming in some cases an obligation In France, we can't take the flight for certain for minimum distance. We need to take the train for certain destinations. So what's your view on how KLM and your activities are looking at that aspect from a business model impact?
Yes.
And leveraging AI, of course.
Yeah, well, that's a very good question. And here, just I want to make a point that, I work for KLM, but some of the knowledge I share is also comes also from my academic experience. So it's a mix of opinions that I formed throughout the year. So in such questions, I don't sometimes fully represent KLM, meaning that it's also something that I see outside KLM happening in my broad overview of the industry. So multimodality is one of those topics that I have a broader overview as well, because that was a topic that I looked into in different kinds of initiatives. But as you said, it's regulated anyway, and it's forced sometimes. So the example of France is like a very indicative example of where things are going. Or, for example, just a personal example, I was talking with my sister who lives in the Nordics, and she started talking to me about carbon credits and how the executives in her company cannot fly if they have exhausted their carbon credits previously. So those different discussions are, of course, very, very important for airlines, and that's something that when you take into account. So multimodality is coming, and even KLM and KLM also is I think that KLM is a front runner on that space as well. So we try to see what are the solutions in short-haul flying. An example is that some of the flights to Brussels are being replaced by trains in coordination with, let's say, the train companies that perform those routes as well on the ground. But of course, that's a start, and we're going to see more and more developments in that space, either as initiatives coming from the airlines, also as initiatives coming from the regulators or the governments. I think that we're going to see lots of those initiatives in the future, and for me, that's also an opportunity, because here's the thing. We discussed, you mentioned the hub and spoke, or you mentioned point to point, but there are for now it's very concrete. So it's either hub and spoke, it's either point to point. But we might also start seeing more hybrid models here, which means that let me give you an example. An airline can fly to smaller regional airports, and those regional airports they used to be your a final destination by definition based on the airline model. But if those airports have good train connectivity, they can act as micro hubs, for passengers traveling in the local area. So we're going to start seeing this kind of logic being implemented, where we don't have major hubs, and let's say then all the rest destinations are mostly terminal destinations. But we can start seeing this kind of hybridization of the models, where you don't have just this kind of duality, but you can also have a mix of different modalities. So it can be aircraft, it can be trains, it can be we see the introduction, and we see all kinds of developments in the urban air mobility and eVTOL space. It can be electric cars, or even hydrogen cars in the future. It can be a mix of things. So for sure, the industry is going to be disrupted at some point, and the way that things are going, it's still not totally clear. So let's say our job is to understand the dynamics and make sure that first of all, we don't miss those developments. Second, we facilitate those developments in a way that it's good for everyone, and it's also good for the environment in that sense.
Yeah, it's interesting what you say, because when you think about those models, where behind there's a lot of code-share interlining agreements, and we'll can imagine having many new actors there. So it's gonna really transform the way airlines collaborate and actually make money, because the rules will change a little bit. And I was just a side comment, which from a consumer is always a big question, is now when I fly to London, my flight is so cheap. What is really expensive is when I go from London to wherever in the city center. It's that's the core. So you're that's crazy in a way, because the metro is much more expensive than. So it's interesting to see that the value chain, there might be a kind of reset on how we see that value chain. But having said that, as we're talking about the customer experience, what's your view there? Are there do you believe there are some some interesting gains where AI data-centric approach can really be leveraged to enhance the customer experience, the flight customer experience, for example, or in airports?
Yes, definitely. I will start with a disclaimer that this is a sensitive topic for every airline because that goes into the core of the revenue management of every airline. And of course, sometimes the general public, likes to think that, airlines are like highly profitable, and sometimes that can happen. But in general, if you see the profit margins of the industry are like pretty thin in general, which means that whatever change you make in the core business model and operating model of airlines needs to be very, very careful design, because otherwise, that might be quite quite disastrous, for a company. So, I start by this. However, again, KLM and Air France and Transavia are the same group, or we have SkyTeam partners as well that work with us. And an interesting topic over there is that Air France and KLM, they have a shared network, so it's optimized in a way, but that doesn't happen with every partner or every airline, and that's a very difficult thing to do, especially because data sharing and in general, the way that you design those very, very complex networks, as simple as that, we didn't have the capacity in terms of tools and, let's say, processes to make things more, to optimize things more. However, again, with technology being advancing, and we can identify more opportunities, so we can develop networks that they have less waste. And when I say waste, I mean develop networks that we fly. The aircraft fly less with, let's say, the same or even higher value. I think that's value for the customer's, value for the airline itself, and so on. Because, again, as I briefly mentioned before, there's a lot of things to optimize, solutions that we currently use as an industry are suboptimal. And interestingly enough, I was having a look and discussing this exact topic with some people from the shipping industry. I was discussing how networks is built in the oceans. When you have to have huge fleets of ships with very complex logistics and very complex cargo. And that thing needs to be optimized in a way that you need to reach specific ports at specific times with specific load for a huge fleet. And there I see that but also the shipping, the maritime industry is also at the start of this journey, meaning that they start exploring how data can improve their operations on that front and the network. But due to its complexity, that's still a problem that it's ahead of us. We need time. So it's the exact same issue with, I dare to say that airlines are a bit more advanced in that front, but there are good reasons for it as well in the way that we're structured. But in general, there's lots of room for improvement over there, when it comes to network and the models themselves. But again, I would say, that's again a personal opinion, I would say that we should proceed with caution, because, in one hand, we have this kind of journey towards better network and better operational reality, but also we need to keep in mind that those kind of changes need to be very, very well designed and implemented, so they don't really disrupt the core business of a company.
Yeah, definitely. So you mentioned early on that you were also looking at the emerging technologies. So let's now try to move further in the future. And there's three areas I'd like to discuss about related to emerging technologies. The first one is back to sustainability. I know it's an important topic at KLM. As I mentioned, KLM has been pioneering the sustainable aviation fuels when it got there. So and we see that there's different options. for the future in terms of sustainability, fuels, or engines. What is for you, from your expert view, the viable and feasible options for that future? And this probably depending on the type of use cases or trip that the airline would be operating.
Yeah. Well, that's again a very, very relevant discussion, very contemporary discussion in the industry. So, if I want to categorize a bit how the future looks like right now, I need to make the distinction between different technologies. So, in one hand, we have battery electric aircraft or even hybrid electric aircraft that are being developed right now, and there are like some very promising startups in the Netherlands doing that, but also, let's say, in the Nordics, there are some really nice developments there. I'm gonna get there. The second solution that we see, and it's heavily supported by Airbus, for example, and the French state, and also, let's say, other main stakeholders, I think the German state too, is hydrogen. So hydrogen is like one of the solutions that we see as being, very promising for the future. And of course, like there is a very big discussion about what we call sustainable aviation fuels. And this is an umbrella term that describes different types of fuels, so describes aviation biofuels. It also describes synthetic fuels, so basically generation of fuels by using CO2 that you capture from the air. Like this kind of soft term describes all those different, let's say, fuel solutions. Now, every technology has some pros and cons, obviously. What I see is that right now we have, like this kind of, unified approach in things, meaning that, we use kerosene, we use like jet fuel, and then that's like what we do from the smaller aircraft to the bigger one. But like moving into the future, most probably that won't be the case, or at least the way we see it now. So in the more regional short-haul market, I think electric aircraft or battery electric or either hybrid electric, like for like a bit longer range, this is where we see this kind of implementation. And of course, some environments are not suitable, but some environments are very, very suitable for that kind of technology. I have two examples in mind. One example is inter-island traffic, and I was involved in a project with the Dutch Caribbean during my academic term, where some islands in the Dutch Caribbean, they investigate the prospects of replacing their conventional flights with electric ones, as long as they are available. And that's very relevant there because like the distances are short. The aircraft that currently operate those routes are small as well. Like think about the twin otter, like aircraft like that. So you can really have like a drop-in replacement of the previous technologies with the new technology, like the electric one. By the way, I'm Greek. I see the same paradigm in like Greek island hopping. That can be also a solution. Or in the Nordics, where like remote communities are not connected by road, or like the road traffic. The road trip can be pretty long, and then you can fly very shortly from one destination to the other. And if you think that, for example, Norway produces like something like 98% of their electric energy from hydropower, in the end you have electricity which is green. Of course, like there are concerns about hydropower and the ecosystems. I won't go into this discussion. That's a separate discussion. But essentially, you produce electricity with essentially zero CO2 emissions, and then this electricity can power those aircraft connecting all those communities, which is like a very good example of how electric aircraft can be deployed. Then you have hydrogen, and hydrogen, like Airbus announced, I think it was over 3 years ago, a zero initiative where they plan to develop aircraft with conventional turbines, but those turbines, they burn hydrogen. Hydrogen has like this kind of particularity that it's very light, but it's very it takes more space than kerosene. So you don't have like a weight issue, but you have a volume issue. So they try to address this topic of volume, and of course you need to keep hydrogen either in very, very low temperature or very high pressure to keep it liquid. So that's also something that you need to take into account. But there are solutions for it, and there is like a whole big technical ecosystem working those solutions. And the front runner is Airbus, of course, like developing those solutions. This is something promising. And Airbus announced last week that they're partnering with another airline and airports in the Nordics again. Like I think the Nordics are really front runner there, but also the Netherlands has like a strong interest in those kinds of solutions. To try and explore how could look like the supply chain of hydrogen on an airport level, so it can facilitate those kind of technologies and types of aircraft. So that's promising, and I see that, let's say, in this kind of narrow body segment that we see right now. I think this is more or less the segment that we see being interesting, this kind of hydrogen solution. And then, like for long haul, or let's say not just long haul, but because in long haul, that's for now the only envisioned solution is SAF, sustainable aviation fuel. So let's say if we see like big aircraft, then batteries are very heavy, and hydrogen, it's very voluminous, which means that we cannot really see how it can be used in long haul. But SAF is like a very ideal solution, and SAF basically can be again a drop-in fuel, meaning that you can just replace normal fuel with SAF. By the way, KLM again is a pioneer when it comes to the use of SAF. For let's say a long time, we use high amounts of like relatively to the other airlines, high amounts of SAF in our operations. But still, the big picture is different because production of SAF is still quite low. So the problem there is scalability. How can scale up production of sustainable aviation fuels? Either biofuels, but then you don't want to compete with feedstock, or synthetic fuels, but there you need high amounts of energy. So the question there is how you can produce this energy to produce synthetic fuels. And of course, there are like all kinds of discussions about, big wind farms, or countries like France that they run on nuclear energy. For some countries that might be a solution. But this kind of discussion is pretty diverse, and right now this consolidation is not there yet. But we see some glimpses of consolidation here and there, like such as one I mentioned before, that different parties are partnering to produce this kind of vision and new value. So, we'll see where things will go, but we have some very experienced and very specialized colleagues working on those kind of initiatives. We're also exploring, how research does in that domain. Another solution, of course, and that's a midterm solution. It's, let's say, the newer generation of aircraft every time is more fuel efficient. So currently, KLM has placed a very big order of very fuel efficient aircraft. The Neos, A320 family Neos, and also A350s from Airbus. And of course, some of you might have seen some, concepts that we developed with other partners such as Airbus and TU Delft. One of those is this V-shaped aircraft. So this blended wing body aircraft called the this blended wing body aircraft, which is called with the V-shape. Which can also improve aerodynamics and so on. So it's it's called the Flying V, and it's also provides an improvement in the aerodynamic side of things. So we see a mix of different technologies, but for me, the most important part is commitment. It's also partnerships, because in this kind of landscape, no one can achieve the final target by itself. So we need to have partnerships over there, and we are very well into this kind of discussion as a company, and personally, I really try to understand what's going on out there in this kind of space.
Yeah, I think it's in a way reassuring that there are solutions out there, but also it's wise to imagine that it's going to be a mix. There's not going to be a one fits all, and I think that's which kind of complexifies definitely the infrastructure aspect of things, but it's probably the necessary step forward if we want to make the aviation greener. Staying in this same line of discussion, I like to talk about the new type of aircraft, the eVTOLs, the famous eVTOLs that we see in the press. And there'll be a lot of episodes around that domain, because it's something which is coming. So for the audience, eVTOL stands for electric vertical takeoff and landing. Mm-hmm. A lot of people talk about flying cars or big drones, but they're really one of the future aircraft that we'll see more and more in the cities. There's already going to be some, mini operations during the Olympic Games in Paris. So it's things which are coming, and they're powered by electric engines, which are themselves either powered through batteries or through hydrogen fuel cells. So one of the things which is really interesting about eVTOLs is you can land from anywhere, take off from anywhere. So kind of just a bit some of the approach we used to have in the airline, which is scheduled, based. As we can now imagine that it's going to be more like a Uber type of service, like a just-in-time service. So, what's your view on, maybe from a KLM or more from a general, your expertise, knowledge on the industry, on those new the impact of those new aircraft in the future for an airline?
Yeah. Well, frankly, talking about eVTOLs, and there are some companies that they made tremendous progress in this domain. So we have prototypes flying, and I think they're even close to production, if I'm not mistaken. So those products are, well, essentially ready. However, like we see that their range and their capacity is, well, not comparable with the types of aircraft that we operate as airlines, at least, let's say, the types of airlines like legacy airlines such as KLM. Well, maybe for regional airlines that might be a solution, but for us, however, well, we see them they're in our radar, but we don't see those technologies as competing technologies or as technologies that they can play major role in the fleet. However, something which is important, and I think you gave a glimpse there, is that there are going to be something like flying Ubers. So essentially a solution, and I think a very good solution, is that you can use those kind of services as, in order to feed your hubs with passengers, especially passengers that come from areas with, not that with compromised connectivity. Well, not just in the Netherlands, which has a very good connectivity, but think about outstations, for example, like places in the world that, getting to the airport from remote areas might be challenging. And this is where I see a very nice case for those kind of, let's say, devices. And of course, something that you mentioned already is like, given the fact that they are electric or they burn hydrogen, those kind of, shall I call them aircraft? Yeah, I guess they're aircraft. Again, they are sustainable by design, which means that, especially given the electrification of the fleet and also the decarbonization of the energy mix in the different parts of the world. So I think that's a very, very good solution to use to make sure that your passengers can make it to the airport. But there might be also solutions beyond that kind of application. But we just need to wait and see, or just create ourselves those solutions. Very interesting topic, by the way.
Yeah. We are looking at that evolution really closely. The third aspect I wanted to discuss with you about is the autonomous air mobility. That's a core, debate with AI. The first point, is it really a reality or fiction? Can we really think that regulation will adapt, or what is going to be the gray application where regulation will be, okay to deploy such technologies? But in such ways, what does it mean in case? I mean, everyone has this question: if there's an accident, as we've seen also with autonomous car, what's going to be, how is it going to work with insurance? And it's a car accident is one thing, but a airline accident, we know that it's really even more dramatic. So it's all those topics. How is this being perceived from an airline perspective?
Well, it happens that I'm very familiar with this topic, and the reason why is because for quite some years, let me give you an introduction. There is international expert group led by SA International in the US called the G34 and by UK in Europe called the WG114. And this joint community develops standards towards certifiable AI. And what I mean with certifiable AI is the following. Aviation is a highly regulated industry, which means that whatever you do, especially when it comes to safety, you need to have some kind of permission and some kind of authorization to act on it. By introducing AI in all kinds of different processes within an airline, if there is a safety component over there, this needs to be approved by the regulators. And those regulators, like the most famous ones, are like EASA in Europe, the European Aviation Safety Agency, and the FAA in the US, the Federal Aviation Administration. So the FAA in the US and EASA in Europe, they need to certify whatever entails any kind of safety concerns within an airline. So it's not just, we're going to develop as an industry something which is AI based and we're going to start flying it without, making sure that this is totally safe. Now, going into the working group, this working group consists of people coming from the whole spectrum of the industry. So I'm talking about the OEMs, and then think about people from Airbus and Boeing and Embraer and Bombardier, and even smaller startups and so on. Think also about airlines. Well, KLM is a member of this group. Also, other cargo airlines are part of it too. Think about also research institutes. Think about universities. Even Eurocontrol is part of it. The regulators are part of it. So basically, tier one manufacturers, so component manufacturers for aircraft, are there. So literally, the whole industry is part of this working group. And I was very lucky to be the chair of two subgroups within this community. So basically, I used to co-chair the data management subgroup and the machine learning design subgroup as well, throughout the years. I used to do that for 4 years. I stepped down at some point because other people had to take over as well, as an experience. But that was just to say that that's a topic that I know pretty well. And what does this community do? Is that we come together and we develop some kind of practices that we seem as necessary to describe and make sure that they are being followed very, very thoroughly. So it's a very thorough description of the process that we need to develop and the technologies in order to make sure that you can trust your AI models. And when I'm talking about AI, well, many people might think about flying planes flying autonomously, but that's not, that's, let's say, the very far in the future. For now, we're talking about applications in maintenance, for example, because right now, whatever we do in maintenance needs to be inspected by a human operator. So some, let's say, cases, especially less safety critical, and we start gradually, can be made autonomous. And then we talk about also applications in air traffic management, just to reduce the workload of the air traffic controllers. So it's about applications that basically support people in order to make to make their life easier and do their work more efficient as well. Now, of course, there are lots of discussions, and these days there's also some pretty big disruption in the Netherlands by the pilots who, of course, and rightfully have concerns about implementing AI in the cockpit, reducing, for example, passing to single pilot operations. But that won't happen soon, in my opinion. So in my opinion, we're going to see AI supporting people, AI supporting engineers, supporting air traffic controllers, supporting pilots. And that's to, first of all, enhance the safety and also reduce the workload and so on. Well, for the future, if things go well and, for example, you see such a market, things might change. But in fact, based on the different statistics that we see, there's going to be, if we keep growing, aviation keeps growing with the same trend as now, we're going to see a pilot shortage at some point, especially with the growing Asian markets right now. Well, if we reach that point, maybe there's going to be a discussion about what to do about it, but that's not the case right now. But in any case, I see AI being gradually implemented in different parts of the processes and the aircraft and the maintenance and traffic management and so on, but in a way that it's very controlled and very safe for now.
Right. So thank you for that. We're reaching the last part of our podcast, and I'd like to focus a little bit more about the ecosystem domain, which is a foundation of the aviation industry. Everything is about partnership, working with. I mean, no one can supply everything, do everything. So it's really based on partnership, and I mean the interlining code-share agreements between airlines just demonstrate that you cannot cover the whole planet by yourself. So as we're talking about AI and data, I like to come back about the data exchange challenges, and I see that you're a really active member of the AOD, which is the aircraft operational data. And the challenge which I've come across myself was that there is some kind of issues to share data between stakeholders. Airport cannot share always all the data with the airline because their business model, the way it's designed, would be a problematic. If passengers are late because of the airport operations or the ground handlers, then they're supposed to pay a fee. And on the other hand, if it's the fault of the airline, so already just with this simple case, we see that there is a kind of a issue to share the data, and it's not a technical problem after all. So can you and we see that this is critical to unleash value, when we just think how complex it is in the airport experience to go through all the security checkpoints, which are checking the same thing, the same person, but by different stakeholders. From your experience and your role in the AOD, do we have a chance to really move forward in terms of data exchange? And do you have some concrete cases where we actually have that collaboration happening?
Yes, well, again, that's a core topic of the things I do. So that's a very interesting and important, in my opinion, question. But of course, I'm a bit biased. But I'll try to give you an overview of what's going on in the data exchange domain because, well, it's not self-explanatory that data exchange is an important topic. But if you dig deeper a bit in the different use cases over there, you can realize that this is a very important topic. And let me give you a couple of examples as you started. You started with the airport, which is like a very valid example. I'll give also a second example, and that's I'm going to go back into maintenance as well. So think about the following case where aircraft generate data, and those data being generated are being used by the different airlines to get an understanding of the health of the aircraft itself and how the aircraft, what's the physical status of the aircraft systems and if they need maintenance and so on. So basically, using data to understand the physical condition of the aircraft is, and perform maintenance is called CBM, condition-based maintenance. And also, if we take that a step further, you can use data to predict the maintenance needs of an aircraft, and that's called predictive maintenance. Now, think about the following scenario. Well, we are fortunately, a very, very safe industry, which means that we don't see many catastrophic failures happening very often. However, sometimes, due to all kinds of reasons, we see, things that they fail, and then those failures might, have some consequences. And I'm not talking about safety because, again, we're very safe, but also it's about operational disruptions, meaning, for example, you don't like to be stranded in the other side of the world because your aircraft broke, and then you need to wait for an aircraft to fly there from the Netherlands to pick you up and come back and so on. And of course, then for the airline, it's a huge logistics and very costly problem to maintain this aircraft being in an outstation on the other side of the world. So that's also something major. So here's the thing. You can predict to let's say a reasonable degree those kind of failures, and you do that by using your own data as an airline. However, if you see the aircraft that KLM operates and the aircraft that other airlines operate, not just allies, talking about Air France or let's say SkyTeam members, but also competitors. We all use the same aircraft type, right? We all use the Airbus and the Boeing types, and even Embraer or smaller aircraft. But in general, more or less, we have the same aircraft types, and we face the exact same technical issues most of the times. So it's really a pity that every airline is using their own data pool to train algorithms and models to predict that kind of issues with the aircraft, whereas we could centralize data and then use a much greater pool of data, which makes those predictions much more accurate in order to predict the same kind of issues, because this way everyone can benefit from it, right? But that doesn't happen. And there are, so this data centralization doesn't happen because law prevents it many times. So those data are, it's prevented by law many times to cross even borders. So basically, you cannot partner with other airlines in different countries. It has to do with data ownership as well. So there's like a very long discussion about data ownership between the airlines, the manufacturers, so the OEMs, with the lessors of the aircraft, with the maintenance organization. So every different partner has a stake in the data. And because of this discussion, data sharing is very, very difficult, because in the end, everyone can claim data ownership over this data. So we see the value there. So it's also about what we discussed before about how you can build, more efficient networks, like with your partners. It's about sharing data, and sometimes there's a willingness to share data, but all kinds of external reasons prevent you from doing it. Now, there are some initiatives on that too, and I'm happy also to be part of such initiatives. So we have the IDCA, the Independent Data Consortium for Aviation. And again, this is a consortium where, let's say, it's an independent consortium, so there's no single ownership of it, and different partners come together, major partners, to discuss what could be a platform and what could be a standard and what could be, let's say, even a template, if I may, that helps you understand what is the different interdependencies and different conflicts when it comes to data, and try to resolve those issues in a more organized way. Because right now, most of those issues are governed by bilateral agreements between different partners, and then that makes the problem even more complex. That's one thing. And the second thing that we explore as KLM, and we hope that we can also expand the scope as well, is technical solutions to it. So, for example, one of those solutions is what we call federated learning, and this is think about AI. You need a central, usually with traditional AI, you need some kind of central data center where you centralize data, and then you consume those data locally by an AI algorithm. Federated learning is the opposite process. So you decentralize data. All the data stay in the data centers of every individual member, and then you decentralize the algorithm. So basically what you do is that you process those data locally with instances of the algorithm, and then you aggregate the results in the end. So this way you don't expose any data, not just sensitive data, but any kind of data to unauthorized parties. So that's a solution that we try to also promote, and we have some both business and research initiatives within KLM to explore with this kind of technologies. But because we see the value there, and we think that the value there can literally take the industry a step forward as well when it comes to maintenance, when it comes to, as you said, processes at the airport or ground, or those kind of things, and partnerships when it comes to network and revenue management. So the scope is very broad. So we need just to make the start, and then I think the use cases will come naturally to us.
Right. It's incredible when just by explicitting a couple of use cases, how critical this topic is, and I don't think people really see how.
And it's not evident. It's not evident. That's the interesting part of it.
Yeah. So I have one last question, which is just around the infrastructure, and you touched base quickly about it, as KLM also is trying to see foresee those aspects. Is with all the changes, the new types of fuels and so on, there is some key question about how we are going to enhance the infrastructure, the processes. One being, for example, if we move to hydrogen, how are we going to store, how are we going to distribution of hydrogen or any energy has a cost. So there are also solutions which enables to store that energy or those mean of energies locally. Is there some start of assessment or research around that from an airline perspective?
Well, Definitely, there is one. Again, we have a very structured way with which we approach this problem, meaning that we have people looking into technology, we have people looking into the infrastructure, people looking into how those kind of different disruptions can affect our models, like our operational models and business models. So yeah, there is interest in like we approach this topic in a systematic way. However, there are like a couple of points that I'd like to make here. One point is that KLM, even though KLM is like a fairly major airline, it's just one player into, let's say, a whole ocean of different potential partners, which means that that tells me that no one can solve this problem individually. So my message and my wish is that we're going to see more partnerships in this domain, because in fact that's a problem. And I'm not talking only about the infrastructure problem, but I'm talking about the global climate emergency problem, sustainability, and so on. This is like it's beyond one airline scope. It's like a problem that touches upon, let's say, the industry and, if I may, all industries right now. So, we're very welcoming into all kinds of different partnerships initiatives that can help everyone address those issues, understand what those issues are, and like identify the best ways forward with those issues. That's one thing. The second thing I'd like to mention is that, in the past we used to see, reluctance or like fragmentation and so on. But as time progresses and like everyone sees like the importance of the topic, I'm pretty optimistic, because I see people approaching to us, like people come to us, or like we do the same with others as well. Because again, I think we see the value. And again, KLM, I'm talking now both, like as a KLM employee, but also like on a personal level, like we're very committed to this problem. Well, the only thing, and I think that's, a message, is that aviation is a very, very difficult industry to decarbonize. So, unfortunately, things cannot change overnight. We do the best of our efforts to make sure that things will progress, but at the same time, like people keep flying, and we're happy about it. But we see a very clear trend when it comes to the automotive industry, for example, towards electrification. With the airline industry and aviation in general, it's not that simple, for the very, very simple reason that the aircrafts need to fly, which means that like weight is very critical. Also, safety is very critical, which means that you cannot really develop products easily that can address those issues. So decarbonization of aviation is, for me, it's one of the most difficult topics right now when it comes to to technical topics, when it comes to their difficulty. Globally, a very, very difficult problem. But again, I see commitment. I see people that they want to go and make sure that this topic is addressed. So I'm pretty optimistic about those efforts. But it takes time, and it takes partnership, and it takes lots of discussions and actions and so on. But yeah, on a personal level, but I think also on, let's say, an industry level, we are committed because we see why we're doing this. Yeah, that's my comment on it.
Well, thank you. That's a perfect closing comment, I would say. It's been a pleasure and really instructive to get your insight, Asteris. I think it's your experience is really impressive. I mean, you've seen so many aspects and you're active in so many domains. So a warm thank you for your time and your sharing all that, your knowledge with this podcast.
Thank you very much for having me. It's been a pleasure. It's been an honor, and I'm very happy that I've been able to share some parts of my work and some parts of my thoughts about the future of our industry, which we all love a lot. So we want to see the industry succeeding and progressing in the future. So that's what we all care about. And I'm confident that we're going to achieve this. Thanks a lot for having me.
Thank you, everyone, and see you on the next episode of our Creating Value in Travel and Transportation.
Thank you for watching or listening to the podcast, Creating Value in Travel and Transportation, from Fairval. If you enjoyed it, please give it a thumbs up and subscribe to it. We welcome your support, feedback, and suggestions, and we hope to see you at the next podcast. Fairval, Creating Value in Travel and Transportation.